system is built of the LabVIEW program, the compact RIO, power supply, 12 volts, and a sophisticated oven with a LED lamp, cooling fan, and a thermocouple inside. On the LabVIEW front panel you have an input. It's now 42 degrees, as you can see, and you can change it to whatever you want. You can change to 24. That will start the fan. You can go to 55 and the lamp will start. You put in whatever value you want. The oven has 4 LEDs, and there's one that represents the warning when the temperature is more than 55 degrees. There is one when you go into cooling. The fan activates and this LED lights up. There is one for heating. The lamp activates and this LED lights up. And the last one is for the LabVIEW safety switch. When the switch is turned, the LED light will warn you about it. Inside we have a thermocouple, the green thing that measures the temperature in real life, and gives us the temperature on the LabVIEW front panel. Here you have numerical, here you have it in a graph, temperature versus time. We have implemented a master override toggle switch on the LabVIEW front panel, this one. When the switch is on, a warning light will be shown on the oven and it will be disabled. To be able to use the oven again, you have to turn the switch and then everything will start working. This is the LabVIEW coatings. We have the safety switch, and it goes into a true or false loop where you measure the temperature, and it goes into the PID, the error, the difference between the measured and input temperature goes into the PID. There's the P, derivative, and integral value. They all go into a check that gives the signal to the lamp or the fan. When this is activated, we can go into the front panel where you can control the system. We'll now heat up the oven to 42 degrees to show that we can maintain a stable temperature and have no overshoot. We activate the safety switch. Lamp goes on and the temperature rises. The temperature has now been stable for 2.5 minutes, and we will take it up to 56 degrees to show that the warning error and the system safety will activate. When it hits 55 degrees, we get a warning message in the LabVIEW front panel. The lamp will shut down and a warning light will be shown. Now the temperature is 55 degrees. The warning light will activate. The lamp goes off and the warning light is turned on. We will now cool the oven down to 32 degrees to show that it will effectively maintain the temperature and have no undershoot. The fan starts to work and we cool it down.
Okay, here we have the cooling process. As you can see, the response is fast as we want, but during the cooling process in the steady state conditions we have some problems. When the undershoot appears, we can see that the system starts an oscillation, and that might be a problem because we are not going to have an stable signal. Okay, after more or less 1 minute, we can see that the system starts an oscillation, and as I said, this can be a problem. We can see here the undershoot and the overshoot of the response.
It's expected to be flat. It's mainly calculated. Most people say it's single calculation.
So we would like to achieve a more stable response, and that's why we will implement some modifications in the system.
We'll now do the cooling down to 32 degrees to show that we have no undershoot during cooling and that we can maintain a stable temperature. It's now 55 degrees and we go for 32 degrees. Cooling starts with the fan. You can follow the graph and the temperature.
Slow down, we've got time left to be lazy. All the kids have bloomed from babies into flowers in our eyes. We've got 50 good years left to spend out in the garden. I don't care to beg your pardon, we should live until we die. We were barely 18 when we crossed collective hearts. It was cold but it got warm when you barely crossed my eye. And then you turned, put out your hand, and you asked me to dance. I knew nothing of romance, but it was love at second sight.